Alright, this is a video to help some of my grade 8s out. On Friday they have their mid-year review, and so we've got some review materials to go over. This is covering using models to represent multiplying and dividing of integers. I'm going to use it just drawing here with my trusty whiteboard markers, and we are going to use black as the deductive or negative color and orange as the positive color. So here are some models that we can use. It says use a model to represent each product. Draw the model you use each time, and it says -9 times +4. So for this one, I can definitely have -9, 2, 3, 4, 5, 6, 7, 8, 9. And those are negatives, so they are being minused from the equation. And it says times 4, so that would be 4 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we have positive 4 rows of -9. Now if I do this symbolically, I have 9 times +4. Now, one of the main rules that we always have to remember is a positive and a positive equals a positive. A positive times a negative equals a negative. A negative times a positive equals a negative. And a negative times a negative equals a positive. So here we have a negative times a positive, negative times a positive. So it's going to equal the negative number, and sure enough, here we go. We've got -9, -18, -27, and there's a total of -36. And so that's the model we're using to show. The next one says -7 times -5. Now for this one, we're going to need to represent, well, a heck of a lot of dots. We're going to need to have -7 times -5. So -5. So let's get -7. We have 1, 2, 3, 4, 5, 6, 7. But we need 5 times that. Now while I'm drawing this, I'm just going to remind you that when we started integers, we talked about how everything in the universe has an equal and opposite. Even matter itself has positive and negative. So for every integer, we must presume that every positive has an equal and opposite negative. So here I'm putting equal and opposite positive and negative to show my integers. Oh, I only did 4 rows. I was supposed to do 5. Let's get the 5th. There we go. So we now have 5 rows of 7, but we have a positive and negative integer for each. Now the original question that we had was -7 times -5. That's where we were. So what we want to do though is we want to get a negative and a negative. We know we're going to get to a positive. So we have -7 times -5. So we're actually getting the opposite of the negative because we have a negative, but we're timesing it the opposite of that negative. So what we're actually doing is taking away the -7. We're minusing the -7 5 times. We're minusing the -7 5 times. Now, I always find that this is one of the most confusing models we have in math. So I'm going to digress and reiterate what we said. Each integer is a positive and negative. We have a -7 times a -5. If I had -7 times 5, I would have had 5 rows of -7. But instead I had the opposite of times 5 rows. I had times negative rows. So I minused a row of -7 5 times. My resulting number is positive 35. Now to do this more symbolically, we look at it as -7 times -5. Remember that a positive plus times a positive equals a positive. Positive negative, negative, negative positive, negative, negative negative equals positive. That's the symbolic rule. Let's get clear again. Sorry, it's not getting as clear as we'd like. Since we have a negative times a negative, negative times a negative, we know it's going to get to a positive. So all I have to think is 7 times 5 is 35, minus a negative is the opposite of the negative, so we end up with positive. Now this is a very complicated model. I know it is a complicated one. It's a little difficult to understand. Please feel free to come in for extra help. I love giving extra help in math, and I have no problem doing it. A glacier retreated 2 meters per day for 7 days. Use integers to find the total length of the glacier. I'm just going to do the symbolic of this. If a glacier retreated, that must be negative 2 times positive 7 days. Negative 2 times positive 7 days. 2 times 7 is 14. A negative times a positive always ends up in a negative number. Will each product be positive or negative? How do you know? Well, we know from the rule that a positive times a positive equals a positive. A negative times a negative equals a positive. But if they're opposite of each other, a negative, a positive, or a positive times a negative, they would be opposite and it would go negative. Negative times a positive, this one is a negative. Negative, negative, that will go positive. Positive, negative, that will go negative. Positive, positive, it will go positive. To do these a little quicker, I'll show you, I'll zoom in. So I know that 8 times 5 equals 40, but I know that negative, positive, it's going to go negative. 5 times 3 is 15, negative and a negative is a positive. 8 times 9 is 72. Positive, positive equals a positive. 12 times 4 is 48. Positive times a negative, it's a negative. Find each product in question 4. We did that. Find each product. Once again, you would just go 20 times 14. And it's a negative to a positive, so it would be a negative. I'll carry on. A swimming pool drains. That sounds like a negative to me. Water every minute. Find how much water is drained out in 30 minutes. It looks like I have negative 35 times plus 30. Well, I know 30 times 30 is 900 and 5 times 30 is 150. So it must be, and it is a negative. Now when we get into here, we're going to go into division. Write 2 related multiplication equations for each division equation. 27 divided by 3 equals 9. Positive, positive, still in the positive. So it says related multiplication. Well, how can I inverse that? Positive 3 times positive 9 equals positive 27. 27 divided by 3 is 9. 3 times 9 is 27. 14 divided by negative 7, positive to negative goes into the negative, is a 2. So I can take the opposite. I can say negative 2 times negative 7 equals positive 14. I took these numbers, switched them into multiplication. Let's check my answer. 2 times 7 is 14. A negative and a negative equals a positive. This one can be difficult. Let's take a look. Positive 20 divided by positive 4. This one looks difficult at first. Take a look. You did this when you were a really small kid. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Well, we've got 20, and we're just putting them in groups of 4. You did this when you initially learned how to divide. You just had 20 divided by 4. But we're going to have some problems here. We're going to get into a positive divided by a negative. Let's take a look at that. I'm just going to use dots to make this a little quicker. So we've got positive, and we're going to do it into 8 groups. So 1, 2, 3, 4, 1, 2. Now remember, for every positive, there is a negative, and we must never forget that. So whenever we're dealing with negative integers, we always have to represent them starting with a positive and a negative. Let's see if you can see all that. So on your screen, you have 32 positives divided into the negatives. Now, I'm going to show this symbolically first. I know that 32 divided by 8 equals 4. I know a positive and a negative is going to result in a negative. So I'm going to end up with negative 4. So we need to find out how many groups. Well, first, I know we're going to end up with the negatives. I'm going to go divided by negative 8s. Divided by a negative is going to get rid of the positive. So the very first thing we're going to end up with is dividing into the negatives. We're going to get rid of those positives. We're going to divide them into groups of 8. And we end up with negative 4 groups of 8. I hope this has helped a bit. If it doesn't, please come in and see me. I expect that you will have some questions, and I look forward to your quiz on Friday.